We're getting ready to start multiplying and dividing rational expressions. So I wanted to start with some very simple basic expressions. So we can see here that we have 20 thirds times x squared, and then we have 9/4 times x to the fifth. So we're just multiplying everything together. There's no addition or subtraction at all anywhere in here. Everything is being multiplied together. So what we need to recognize, we could put all our numbers in our calculator, multiply it up, and do MathFrac. Sometimes we don't have a calculator, so what we need to recognize is that I can rewrite this to be 20 times 9 times x squared times x to the fifth. I know 4 is a factor of 20, so I'm going to rewrite this to be 4 times 3. So these are actually equivalent. They are the same. So now when I look at this, I'm going to look at 20 divided by 5. Well, 4 goes into 20 5 times. 4 goes into itself once. So that becomes 5. And then here I have 9 divided by 3, which is the same thing as 3. And then you need to remember your facts about multiplying same base. So here, I'm going to write this out. If I multiply same base, what's my base? My base is x. Then I'm going to add my exponents. So what do I have? I have x2 times x to the fifth, which is the same as x2 plus 5, so that gives me x to the 7th power. So that means these two multiplied together gives me x to the 7th power. So then I have 5 times 3, which is 15, x to the 7th. So this whole expression simplifies to 15x to the 7th. So we have to be careful. We have to recognize this is multiplication. Division is similar, but we have to do something first. Because this is division, we need to change the operator from division to multiplication. Multiplication. And there's two things we have to do. We have to flip the fraction that follows. Okay, it's always the one that follows the division sign. Okay, so let's rewrite this. So this is going to be rewritten as x cubed over 4. Now it's multiplying, and I'm going to put the 8 on the top and the 7x to the fifth on the bottom. Okay, so this is very similar now to what we did here. Instead of reorganizing this out on paper, I'm just simply going to look at it in my head. So I see here that 8 is a multiple of 4. So 4 goes into 4 once. 4 goes into 8 two times. So that simplifies to 2. And now I'm going to rewrite this so we can see it a little bit better. So this is going to be 2x cubed over 7x to the fifth. So right here, I have same base. Okay? So what I want to think about the same base, my same base is x. So now I'm going to use my rules of exponents, but there is a shortcut. So I'm dividing. So what I want to remember is when the exponent crosses the line, the division line, the exponent changes its sign. Okay? So the other thing I want to think about, and so what am I talking about? I'm going to do this in a minute. The bigger exponent pulls the smaller one to it. This is only in division. One's on the top and one's on the bottom. So here, the bigger exponent pulls smaller to it. Okay, so what does that mean? That means this can be rewritten as my 2 is on the top, 7, x to the 5th. That all stayed the same. But this wants to come down. So now that's x to the -3. Notice how it was positive in the top, but because it crossed the division line, it became a -3 in the bottom. So now here in the bottom, in the denominator, I'm multiplying same base. So I'm going to add exponents. So that means my numerator is still 2. And I have 7x. 5 minus 3 is 2. So that is my simplified answer.